I have a question for you. Why do giant companies like Google, Meta, Amazon, and almost every major websites never store your actual password in their database? The answer is hashing, and hashing is one of the most powerful privacy techniques in computer science. Here is why. Unlike encryption, hashing is a one-way mathematical process. Once your password is converted into a hash, there is no practical way to reverse it back into the original password. That's exactly why companies store the hashed version of your password instead of a real password. So even if hackers somehow steals the entire database, they'll only see the thousands or even millions of random looking strings, not your real passwords. That's how hashing protects your privacy. But now the interesting question. What actually happens inside a hash function? How does the word hi and even 10 GB of video file both produce a fixed size output? And why does the same input always generate exactly the same hash? Let's see what really happens. The first thing the hashing algorithm does is converting your input into binary, a sequence of zeros and ones, because computers process only binary, not raw text characters. Then, if the input is too short, the algorithm adds padding bits, so the data fits the required block size. For SHA-256, each processing block is 512. If your input is larger than one block, it simply splits the data into multiple 512-bit blocks. Now comes the most important part. The algorithm starts with predefined mathematical constants. Then every data block goes through the dozens of rounds of mathematical transformations. Operations like bit rotations, bit shifts, XOR, and OR. Every round keeps mixing these bits until the original data becomes completely unrecognizable. Even more interesting, the output from the block becomes part of the computation for the next block. So every block influences the final result. This creates a huge mathematical chain reaction. After processing every block, the final binary state is converted into a hexadecimal string. For SHA-256, the output is always 64 hexadecimal characters. Whether your input is high or 10 GB of movie, the hash length is always exactly the same. But wait, how can a mathematical function becomes impossible to reverse? Here is a simple example. Suppose I tell you 167 modulus 3 which is equals to 2. Now can you determine the original numbers just by looking at 2? No, because countless combinations can produce the same remainder. Similarly, a hash value alone doesn't contain enough information to reconstruct the original input. Hash functions are obviously much more sophisticated than the modulo operation. But this example gives you the basic intuition of why reversing is impractical. Now you might ask, wait, if multiple inputs can theoretically produce the same hash, then couldn't a hacker log in into someone else's account? Yes, this situation is called hash collision. Mathematically, collisions must exist because there are infinitely many possible inputs but only a finite number of possible SHA-256 outputs. However, for modern cryptographic hash functions like SHA-256, the probability of finding such a collision is astronomically small. SHA-256 has 2 power 256 possible outputs. That's such an unimaginable large number that finding a collision by chance is considered computationally infeasible. Think of it like this, winning a lottery once is already incredibly rare. Now imagine winning that lottery every single day for your entire lifetime. That's roughly the kind of impossibility we are talking about. Wow. Modern websites add another layer of protection. Before hashing your password, they generate a unique random value called a salt. The salt is combined with your password before hashing. So even if two users choose the exact same password, their stored hashes become completely different. This also prevents the attackers from using huge pre-computed lookup tables known as rainbow tables. Finally, when you log in, the website never decrypts anything. Instead, it takes the password you entered, hashes it again using the same algorithm and the stored salt, then simply compares the new hash with the one stored in the database. If both hashes match, you are authenticated. Otherwise, login failed. That's how password authentication works behind almost every modern website. And to make password cracking even harder, companies usually use specialized password hashing algorithms like Argon, bcrypt, scrypt, and many more, which are intentionally slow and computationally expensive. This makes brute force attacks dramatically more difficult. Now you have learned one of the most important privacy techniques used across the internet. Comment below. Which hashing algorithm have you used in your projects?